Okay, so what we want to do today is we want to continue talking about the Federal Reserve and its policies. Last time I told you that there were three main policies, three policy tools that the Federal Reserve uses to control the money supply. We'd already talked about the first of those, open market operations. If you'll remember what I mean by open market operations, this is buying and selling government securities. The Federal Reserve does the buying and selling. If you'll remember, this is the technique the Federal Reserve uses to get money into the economy or to drain money out of the economy. I used the example of a helicopter the other day, but the Federal Reserve doesn't fly a helicopter overhead and throw dollars out. What the Federal Reserve does, if it wants to put money in the economy, is it will buy a bond from somebody, either a person or a company or a bank, usually a bank. Well, a bank will have a government securities dealer, but the Fed can buy a bond, and when the Fed takes possession of the bond, the Fed pays by saying, here you go, and when the Fed pays, that puts new reserves into the banking system, new money into the economy. When the Fed wants to reduce the money supply, the Fed will sell securities to the public, either an individual or usually a bank. When the Fed sells securities, the Fed says, here you go, and hands you a bond, and then you have to pay. And when you pay, the Federal Reserve takes that money, and that drains the money out of the economy. Anyway, that is the Fed's most often used policy. This policy is used every week and sometimes every day. But this is just an ongoing part of Federal Reserve policy. Not that they sometimes do it, they're always doing this open market operations, buying and selling government securities. Second policy is discount rate policy. That term means changes in the interest rate the Fed charges banks to borrow reserves. Banks are required to hold reserves against the checking deposits that we put in the bank. And since banks are required to hold those reserves, what if they don't have enough reserves? What if they've lent out too much money and just don't have reserves to hold against their reserve requirements? And the answer is they go to the Fed and they borrow that money. Sometimes, they don't always. But anyway, when the Fed lends reserves to banks, and that's what this is all about, is this Fed loans to banks equal discount loans through the discount window I put some quote marks around these things, discount loans and discount window. These are just informal terms, what they're called. But anyway, the Fed does loan reserves to banks. Here you go, here's some reserves. And I'm saying that a policy is to change the interest rate on those loans. If the interest rate on those loans from the Fed is 5%, bankers will borrow a certain amount. If the Fed would raise the interest rate to 6%, bankers would say, I don't want to borrow so much. If the Fed will lower the interest rate from, let's say, 5% down to 4%, then there would be more banks that would borrow from the Fed. And so the point is, when the Fed changes the interest rate on those loans, by the way, that interest rate is called, and this is going to really surprise you, the discount rate on these discount loans through the discount window. The discount rate is that interest rate. If the Fed raises the discount rate, that discourages banks from borrowing. If the Fed lowers the discount rate, it encourages them. And by the way, this affects directly bank reserves. So if, let me just kind of draw out a little diagram over here. If the Fed will increase the discount rate, that will discourage or reduce bank borrowing of reserves, and that's from the Fed. And then that will decrease total reserves. I used those letters before, the TR, total reserves. That goes down. Banks are not borrowing as much from the Fed, not getting as many reserves from the Fed. And then with total reserves go down, that means there's a decrease in the money supply, M1, by a multiple of the reduction in reserves. So let's say that banks had been borrowing $1 billion typically from the Fed, and now the discount rate is raised and banks only borrow $500 million from the Fed. Then that means there's $500 million less in total reserves in the banking system, and we will multiply that by the multiplier to find out how much the money supply goes down. If the multiplier is 4, then $500 million less in reserves times the multiplier of 4 means M1 would go down by $2 billion. Anyway, but that's how the policy works. It works in reverse as well. If the Federal Reserve would lower the discount rate, that would be inviting, come on in and borrow some reserves. And that would encourage banks borrowing at the discount window. When they borrow more, the Fed just basically says, okay, we'll loan to you and we'll put the money in your reserve account. Total reserves of banks would go up, and therefore the money supply would go up. So if the Fed wants to increase the money supply, one way of doing that would be lower the discount rate. What we saw last time is another way for the Fed to increase the money supply, purchase government securities. These are just two different policies. The open market operation is used all the time. Every week, I said, sometimes every day. Discount rate policy, that changes a few times a year. Let's come up here and I'll continue my writing. The discount rate changes, I don't know, 2 to 5 times a year. And that's just sort of an average year. Some years it may not change. Other years it might change 7 or 8 or 9 times. But in an average year, very few changes in the discount rate. 2 or 3, maybe this year 2, and maybe next year 3, maybe next year 1. So anyway, who sets the policy? The discount rate is set by Federal Reserve banks, with the okay of the Board of Governors. If you'll remember, I drew that little pyramid up here last time. The Federal Reserve banks, there's 12 of them, these regional banks scattered around the United States, one in St. Louis, one in Kansas City. I'm saying each one of those Federal Reserve banks sets its own discount rate. Each one of those Federal Reserve banks, that's where the bankers will go to borrow reserves from the Fed. You go to your regional Federal Reserve Bank. So if there was a bank in Springfield that needed to borrow reserves, it would go to the Federal Reserve Bank of St. Louis, not to just you choose your own. You go to the one the district where you operate. And Springfield happens to be in the St. Louis Federal Reserve District. The very western edge of Missouri, and I mean just a few miles along the border, that's in the Kansas City Federal Reserve District, and then all of Kansas and Oklahoma and so forth. And so if a bank was from Joplin, I believe Joplin is in the Kansas City Federal Reserve District. If they want to borrow, they would go to the Kansas City Fed. If Springfield Bank wants to borrow, it goes to the Fed up in St. Louis. And so each one of those Federal Reserve banks sets its own discount rate, but they don't just go off in their own direction. They have to get the okay. They have to be working with the Board of Governors. And this is kind of an informal thing, this okay, but the way it works, and we talked about the Federal Open Market Committee before, there's that group of 12 that make policy, and that includes both the Board of Governors and the Federal Reserve Bank presidents, so they are all really conducting policy as a group. The third main policy, let me do a little erasing here. The third main policy is reserve requirement policy. Reserve requirements. And we're talking here about that thing that I've been calling R for the last few days. The required reserve ratio, I've used the letter R to represent that. basically the policies that we're talking about is increasing the R, the required reserve ratio, or decreasing that R. That's the policy we're discussing right now. This is done by the Board of Governors. They are the ones responsible for changing that policy. This policy changes almost never. And I'm saying 5 to 10 years. They may come back and make some modest change in the reserve requirement, but it does not change very much. And so really what we have is a list here of policies that are conducted all the time, some of the time, almost never. Okay, open market operations just constantly, and reserve requirements are almost never changed. The reserve requirement right now is 10% for a medium-sized bank or a large bank, and 3% for the smallest banks. Okay, the way this works, changes in the required reserve ratio change the multiplier, the money multipliers. Okay, we used the money multiplier the other day, the simple deposit multiplier, and we're going to come back and talk about multipliers here in a second. We talked about the simple deposit multiplier the other day was 1 over R. Right? And so using that 1 over R, what we're saying is this, is let's say that the required reserve ratio is 20%, then the multiplier is 5. If the required reserve ratio is increased from 20 to 25%, this multiplier becomes 4. So an increase in the required reserve ratio, increase in the required reserve ratio, decrease in the money multiplier. From what, 20% to 25, higher required reserve ratio, a lower multiplier. Why is that? And the answer is this, and again, let me just use an example as opposed to some theoretical explanation. Let's suppose in the first instance that the required reserve ratio is 20%. I walk into the bank, I put $100 down on the counter. The banker must set aside $20 now and as reserves, and will make a loan of $80, 80% of my deposit. And that loan will then, that goes into making the multiplier. That goes into increasing the money supply. If instead what happens is that the required reserve ratio is 25%, and I walk in and I make exactly that same deposit, that banker must set aside $25 and can only make a loan of $75. And so there's less lent out by the bank, so less added to the money supply, less deposits created, and less money created. And so anyway, what we end up with is a smaller multiplier once we start dealing with more of the reserves just being set aside and not being lent out. So that's kind of how it works. But as I say, 10% multiplier, and you know why they use 10% is that's easy to do the multiplication. You know, you get like 15% and you got to get the calculator out. So anyway, over time this ratio has diminished. This required reserve ratio used to be higher, and it has gradually come down from higher levels to where they are right now at this, as I say, 10%. Any questions about this? Okay, well let's finish up this material and go on to more material. Well, let's finish this up by talking about, I just mentioned this term here, the simple deposit multiplier. Let's talk about a more complex multiplier. And somebody asked about this last time, and I said, well, I'll come back to it, so now we are back. The simple multiplier that we've already used is this 1 over R, simple deposit multiplier. What we assume then, we assume this, currency held by the public is 0, and we assume that excess reserves held by banks are 0. And then we went ahead and derived that multiplier. Okay? What we want to do is drop these assumptions. We want to recognize that bankers do hold excess reserves and people do hold currency. Okay, so once we do that, we have to come back. Oh, and by the way, let me put this formula up here that we were also working with, which was total checking deposits in the economy equals total reserves of banks times 1 over R. That was the formula we were working with before to calculate the total amount of money in the economy. This is the only form of money in the economy when people hold no currency. Then there's only checking account money out of that M1. Okay, so here's what we want to do. We want to come back and say currency is greater than 0, excess reserves greater than 0. And so then what we need to do is put up a new formula at this point where we'll say M1 equals B times M, and let me just write a little explanation to go along with that. Now we're dealing with a different kind of money. M1 is currency plus checking deposits. Before we were only checking deposits because people held no currency. Okay, so now we're talking about a broader measure of money. This thing right here is the monetary base. And the monetary base is equal to total reserves at banks plus currency held by the public. That's that C that I've just said. Before, currency held by the public was 0, so before, if we talked about the monetary base, there would have only been the total reserves. The currency held by the public, that was nothing. And this multiplier, you can write this down or not. I promise I will not test you on it. But there is a more complex multiplier. And it takes into account not only people's holdings of currency, but bankers' holdings of excess reserves. And so, and by the way, like I say, write it down or don't write it down. This will not be on a test. But I wanted you to see that earlier what we had was a multiplier that just had the required reserve ratio in it. Well, we still have the required reserve ratio in our multiplier here. There's 1 over, there's an R, but we also, in this more complex world, we need to control for the fact that people hold currency. And these are ratios right here. I won't go into a lot of detail just because we're not going to be working with this. But this has to do with people's holdings of currency. What percent of their total money do they want as currency? And this E reflects how much in the way of excess reserves do bankers want to hold. So we have a more complex multiplier that takes all these things into account. Here's a simple way of calculating the multiplier. I'll take this M1 equals B times M. So I could calculate the M, the multiplier, this way. Divide both sides by B, and it says M1 over B equals, these cancel, M. So a simple way of calculating the multiplier is just go out and get today's M1 money supply and today's monetary base. Today's monetary base is only the bank reserves plus the currency that basically the Federal Reserve's put this currency out in the public, so the Fed knows how much that is, and the Fed knows what bank reserves are. The banks are always reporting to the Federal Reserve on that. So anyway, you find out the monetary base, you find out M1, and the ratio of the two tells us the multiplier. For example, let's say that the M1 money supply was $1,200, and let's say the monetary base was $400, then we would say the multiplier is equal to 3. Now that's the sort of do an end run where we're not calculating it from the ground up the way that we were previously, but we're just sort of coming around in an empirical way and just saying, well, I observe the M1 money supply, I observe the monetary base, so the multiplier must be 3. Anyway, if the multiplier is 3, then here's the conclusion we come to. Well, let me write it down here. M1 equals monetary base times the multiplier, and I just said that's 3. So for every dollar's worth of monetary base, if the monetary base was, you just pick a number, $5,000. If it were the monetary base were $5,000, then the M1 money supply would be $15,000. All right. Another way we can alter this equation, we can put these little delta signs out here and say, if the monetary base changed by $100, another $100 with the monetary base, then we would have a multiplier of 3, and we'd say the M1 money supply would go up by $300. there is really, and the reason we're not going into this further is it takes quite a bit of time, quite a bit of discussion. We teach a course, not we, but I teach a course called Money and Banking, where we go into this stuff in greater depth. But we don't need to go into it in greater depth for us to just understand the basics. We already had the simple deposit multiplier up here when the only kind of money there was deposits. But the same general idea applies when there is currency in the economy. There wasn't before, but when there is currency in the economy, we need a measure of money supply that reflects currency in the economy. Okay, and so we go from DD, checking deposits, to M1, money supply. When there is currency in the economy, we no longer just focus on reserves, but we want to talk about the monetary base. The monetary base is total reserves plus currency. Okay, and then when we do have these other possibilities, the multiplier becomes more complex, and we saw this just a moment ago. The multiplier becomes more complex. We get more variables in the calculation, but the general idea is the same. Yes?
Since the currencies are on different sides of the equation, doesn't they pretty much cancel out?
I'm not sure. Since the currency is on both sides of the equation, won't it cancel out? I'm not sure if I understand what you're saying.
Like the M1 is equal to DD plus C.
That's right.
B is equal to...
Yeah, but they're on... Well, they don't cancel out because there's more than just that, but I'm not even sure if I fully understand your question, but there's more than that. There's also excess reserves, so when we make the move from the old formulation to the new one, we're not just taking into account currency, we're also taking into account excess reserves. But I think the way that you're saying that, there is some canceling that takes place, but what happens, well, let's not get into that too deeply, but it's not a one-to-one deal, because the way the currency figures in here is just in a linear way where we just add. If it's $1,000, we add $1,000. And when currency is adding in here, we're just adding, if it's $1,000, we're adding $1,000. But over here, the currency comes in 2 different times in this fraction, and it's not a linear thing anymore. Anyway, I guess what I'm saying to you is be aware that there's this more complex way of looking at the world, but also be aware that you don't have to master everything in the world to understand just this simple idea that when the Fed puts dollars into the system in the form of bank reserves, then those reserves have a multiplier that we apply to them, and that tells us how much the money supply is, the particular money supply. And then everything past that is just sort of refinements on that general idea. Any other questions? Okay, well, let's go on to the next topic. Let me do a little erasing. The next topic is, it's basically called money and the economy. How does money affect the economy? What we've been talking about is this. In fact, if you go back and think about it, here's the first thing we started talking about when the subject of money came up. We talked about the functions performed by money. Money is a medium of exchange. Money is a unit of account. Here's the history of how money developed. Here's other things that, desirable characteristics of money. It means to be divisible and durable and needs to be, all those types of things that we talked about. Those came down to really what I would call money demand. What are the forces that influence the demand or the desirability of money? And without money serving as a unit of account and as a medium of exchange, without that, money what's the demand for money? Why do people want money if it wouldn't do those things? And so the desirability from people's point of view, the desirability of money is based on the functions it performs. So we started off talking about the functions of money and it's the demand for money. What we've just ended up talking about, and we've been discussing it quite a bit, is the supply of money. And what we've seen is this, is that the Federal Reserve plays an important role in supplying money. It puts reserves into the banking system, but then the banks play an important role also. They have to make loans, and it's when they make loans that checking account money is created. So we've talked about the demand for money, and now we talked about the supply of money, and what we want to do really is now go on and talk about how does the money affect the economy. Okay? Let's start off with a formula called the equation of exchange. The equation of exchange. This is a key element of classical economics, and we've used that term before, classical economics. And so the classical economists, and I'm really talking about economists that were around 200 years ago and 100 years ago and so forth, this was sort of a key part of what they saw as macroeconomics. And I've told you that they really didn't have a macroeconomics the way we have one that's sort of got all the refinements in it. But this was a key part of their early understanding of the macroeconomy. Let's kind of go through and write a little note for each one of these. This is the money supply, the M. V is something called velocity, equals the number of times each year the average dollar is spent. That sound like velocity to you? P is the price level. Q is real GDP. And of course, P times Q equals nominal GDP. That's the dollar value of GDP. And I didn't write them up here, but there's little time signs in between here. MV equals PQ. And by the way, there's 3 lines in there. It's not equals, there's an identity. This must be true by the way things are defined. Okay, now let's go through and talk about this just a little bit. MV, M times V. What does this mean? Suppose that suppose the total amount of money in the United States is, let's say, $1,000. All the money in the United States is $1,000. And I'm talking about currency, and I'm also talking about checking account money. There's $1,000 somewhere, anywhere in the United States. That's the money supply. Suppose velocity is equal to 8, and that is to say, let's don't use 8. That is going to cause problems for me doing multiplication down the road. Let's call it 5. What I'm saying is, of that $1,000, on average, those dollars are spent 5 times a year. Each one of them is. Suppose, to make it real simple, that all there was one $1,000 bill, and that $1,000 bill got spent 5 times during the year. What would be total spending in the economy during the year? You spend $1,000 5 times, $5,000. So this is total expenditure in the economy. P times Q. I'm sorry, M times V. Total expenditure. By the way, in an earlier chapter, the Keynesian chapter, and the aggregate demand, aggregate supply chapter, when we used the term total expenditures, we said, oh, consumption plus investment plus government spending plus net exports. And I'm not taking that back. That stuff is sort of in the background, but we've already come to that understanding. All we've done now is we said, hey, we got a new way to calculate this total expenditure. It's also equal to the money supply multiplied by velocity. Okay, so this MV, this is total expenditure. Total amount of spending for new goods and services in the economy during the year. Okay, what's P times Q? Well, let's say that you're a company. Let's say there's only one company. It sells everything. If you're the company and you're selling everything in the United States, then Q, that's the quantity, the number of units you sell, and P is the average price you charge per unit. And so P, let me put it up here, P times Q. Let's say the average price you charge is $5 and you sell, oh, we don't want to say $5. Let's say the average price is $10 and you sell 500 units. Then this would be your total sales receipts. So over here, P times Q, total receipts from sales. So, you know, this is really kind of an empty statement, isn't it? And very often you'll find that's true when you see the 3 lines right here. This is like kind of obvious. Here's what this says. All the spending in the United States during the year, M times V, all the spending in the United States during the year for goods and services is received by somebody. Ooh, really? Yeah, of course it is. Total spending by people and companies is equal to the total receipts of the people who are doing the selling. So this is not a real insightful statement, is it? But nevertheless, it's a good starting point. This is not the end. This is the equation of exchange. That's what that says. Now, this equation of exchange was altered, or not altered, but used by classical economists to create something called the quantity theory of money. And this is the macro model, the macroeconomic model of the classical economists, this quantity theory of money. They use the equation of exchange. Here's what they do. Let's write it down again. MV equals PQ. Okay? And here's what they did. The classical economists. They came in and they said, assume V equals V bar, Q equals Q bar, that is to say, constant. Or unchanging. The classical economists assume velocity was constant, did not change, and they assumed that real GDP in the economy was constant, did not change. Now, you know, when the classical economists wrote, this was quite a while back. Nowadays, we're used to talking about the economy growing 3% a year or something like that, and we come to expect that. Policy makers are always thinking about how to make the economy grow more rapidly. And so economic growth is sort of something we take for granted. But if you go back a couple hundred years in England, 150 years, and you look back, not just in England, but you look back through the broad stretches of time, and here's what you'll see. You know, economies don't grow very much, do they? And that's really what you could see is if you look back, it took thousands of years. You look back at the Roman Empire to today, and we are living dramatically better than they did thousands of years ago. But on the other hand, for 2,000 years of progress from then to now, the growth rate is not very rapid. A lot of that growth has occurred during my life or during your life. What's the annual growth rate? And the answer is maybe 0.5%, 0.25%, very slow growth. And so the classical economists were saying, you know, real GDP just, and they didn't have that concept GDP. That came about in the 1930s, if you remember our discussion there. But they were saying that basically the economy is not growing much. It's probably pretty stable from one year to the next. And velocity, that's probably pretty stable too. That's what their assumption was. They didn't know for sure. By the way, people of now, archaeologists, they dig up coins from the Roman Empire. I brought up Rome, so I thought I'd throw something in about that. They dig up coins from the Roman Empire, and what they do is they weigh them and find out how much they weigh, and from that, they get information on how much they were worn down by, you know, like coins rubbing against each other or just hand-to-hand use. And so from that information, and then they know what year the coin was minted, and they can pretty much tell when the coin was buried. There are techniques they use. And so anyway, they say, well, we got a certain amount of wear over a certain number of years, and from that information, they calculate velocity going all the way back to the, as I say, the Roman period, which would be 2,000 years ago. They go back and calculate velocity from coin wear figures. But anyway, what the classical economists were doing is, and this wasn't thousands of years ago, just 100 years ago, they assumed constant velocity, constant real GDP. So if you assume that, let's come back to this formula. What we have is M with a V bar equals P times Q bar. That's what the classical economists thought the world looked like. So here's what they were saying. If you would increase the money supply, velocity didn't change. Q, real GDP, didn't change. For this formula to be true, there had to be an increase in the price level. Okay, let's use these numbers that I had a moment ago. MV equals PQ, and I think what I said was $1,000 worth of money in the economy. The velocity is 5. P, I'll say the average price is, what did I say, $10, and Q, 500 units. And that formula, I mean, that's true. Now, let's come back and do this. Assume velocity does not change and Q does not change. And let's just make the money supply now $2,000. If the money supply is $2,000, $2,000 times each dollar gets spent 5 times during the year, there's $10,000 worth of spending now. And if there's $10,000 worth of spending and there's still only 500 units of goods and services to buy, then each one of those must have a higher price. Each one of those must cost $20 per unit. So here's the conclusion that the classical economists came up with, the conclusion that changes in the money supply are matched by proportional changes in P, the price level. Why no change in Q? And you know what they think? They thought, hey, everybody that could work has got a job. If there was any idle labor services, then they would find a job, wages would go down and clear the market, but everybody's working and so there's no change in Q. All the changes in spending, and that's what we're looking at over here, this is total expenditures. All the changes in spending are going to be reflected in the price level. By the way, that's kind of interesting if you think back, and I don't want to take us too far down the detour, but here's what Keynes said. Keynes had a horizontal aggregate supply curve, and he said, oh, well, if there's an increase in aggregate demand from AD1 to AD2, if there's an increase in total spending, total expenditures, and aggregate demand, if that happens, then we get an increase in real GDP and no change in the price level. That was the Keynesian story, increase in aggregate demand. Now what these folks are doing, the classical economists, they're saying if there is a change in total expenditures, the money supply goes up, for example, and so total expenditures rise. Let's draw the curve here. Here's Q and P. If there's a change in aggregate demand from AD1 to AD2 due to a larger money supply and more spending, what these folks are saying, the classical economists, is that the entire change of that extra spending is reflected in a higher price level. Prices will go up, but there's no change in Q. So they have exactly the opposite point of view on aggregate supply. Keynes had in mind we're in a depression, increases in demand, increases in spending don't lead to inflation. They just stimulate total output in the economy and total employment. Now here's the classical economists who say, well, we're always at full employment. This is not only Q, but Q in. They say we're always at full employment. And so any increase in spending that occurs through an increase in the money supply, that increase in spending will be inflationary. It will drive up the price level. They're taking exactly the opposite points of view. Now, by the way, the classical economists came first, and it was their model. Again, they didn't have the graph that we draw. They did it through, verbally talking and doing the mathematical calculations. But this was the existing model, and then along came Keynes in the 1930s, 1936. I told you he wrote that book. Along came Keynes and said, man, I don't buy into that. These guys have got it all wrong, and here's a new model. And so he went from really a vertical aggregate supply curve to a horizontal aggregate supply curve. That's in terms of their understandings of how the economy works and so forth. Here's what this thing says right here. Changes in M are matched by proportional changes in P. Here's the implication. If there's an increase in M by 10%, then there's an increase in P by 10%. That is to say, we get a 10% inflation rate. And you can make those numbers any number you want, like 40% and 40%, 68% and 68, and that's the general meaning of that model. Is it right? And the answer is, no, we don't think it's right in terms of being exactly right, but we think it's a good rule of thumb. Let me write that down here, rule of thumb. We think that's pretty close, but not exact, but pretty close. If you look at, let's say, the United States over time, if you just take not year to year, but like the entire decade, an increase in the money supply, and what was the inflation rate for that decade, and you look at decade after decade after decade, then you'd say, boy, that's a pretty good rule of thumb. That gets pretty accurate. Or if what you do is you look at, let's say, just nations, not break it down by year, but just the United States during the 80s, and England during the 80s, and, you know, and then just go through and pick out different nations during the 80s, then what you would say is, that does a pretty good job, you know. The United States had a little bit slower money growth than in England, and so England had a little higher inflation rate than we did. We had a lower inflation rate, and that does a pretty good job. Where it falls apart is not in these sort of broader averages or broader measures or evaluations of the rule, but where it falls apart is on a year-to-year basis for any specific economy. And so even though it's a pretty good rule of thumb, we don't want to say that's as far as our knowledge has gone. We have gone past that. Okay, so let's go on to something that is more recent. This was the quantity theory money from the classical economists. What we want to talk about now is the modern quantity theory of money. This modern quantity theory of money is something that modern day economists use, not all of them, but some of them. The economists who use this model are called monetarists. Monetarists are economists, first of all, so kind of a low scoundrel, but monetarists are economists, and these are economists who believe that money has a big impact on economic conditions. They're not just economists who think, yeah, there's money out there. Everybody knows there's money. The monetarists say this. You know, that stuff that Keynes talked about is not very important. That's what they say. It's not very important, all that C plus I plus G and fiscal policy and multipliers and so forth. We kind of don't pay much attention to that. We think the quantity of money in the economy, that's what dominates in influencing the economy in terms of creating recessions or inflation and things like that. Okay? These monetarists, they advocate laissez-faire economic policies. Laissez-faire, you remember what that means? Basically government non-involvement in the economy. And they're saying the government, for the most part, does not make the economy perform better. For the most part, makes it perform worse. Okay? The monetarists believe in a stable monetary policy, not an aggressive one. That is to say, they think money is powerful, but they don't want the government, the Federal Reserve, to do very much with monetary policy, really just kind of have a stable policy. Here would be an example, and I don't mean to say the only example, but for example, 4% money growth each year. Okay? What they would say is this is the monetarists, you know, money is very powerful, but if there's too much money, that power is a bad thing. And if there's too little money, that's a bad thing. And so since money is so powerful and it's so easy to go overboard and create too much or have too little, why don't we have kind of a stable policy where the money supply is just growing a little bit at a gradual rate year in and year out? And so monetarists sort of push in that direction. Okay? Since they want this stable monetary policy, they really they want to let the private sector determine Q and employment, you know, economic conditions. They want that just to be something that happens in the private sector, not something where the government's out here sort of trying to crank up the economy in one year and slow it down the next year. Okay, these, and let me give you a name, Milton Friedman. When was he born? I don't know, but maybe about 1915 through, well, you know, he's still going, so we better not be writing another date there. But he's getting kind of old, isn't he? So Milton Friedman, and there are other economists who call themselves monetarists. I'm kind of a monetarist myself, but I believe in a few other things that maybe the monetarists don't. But anyway, the point is there are other economists, but Milton Friedman is the one who sort of was out in front of this group, the modern quantity theory of money and the monetarists. He was sort of the one who was leading the charge throughout the 1960s and 70s and 80s. And so here's what they do. They start off with the quantity theory of money. We see the term again, quantity theory of money. Here's the equation of exchange. MV equals PQ. And by the way, for this part, I think what I want to do is start using GDP rather than PQ. But because those are equal, but this sort of story, P times, or GDP sounds better. This is nominal GDP. Okay, so here's what they do. They say MV equals GDP, and then they divide both sides of this formula by V, and they get this, M equals 1 over V times GDP. That's pretty tame, isn't it? Just rearranging the letters. And then they take out this 1 over V and they put in a K. M equals K times GDP. And that K is equal to 1 over V. So they've started off with the same equation of exchange. However, and here's really the key to all this, now this M is not what it was a few minutes ago. Here we go. A few minutes ago when we wrote this down the first time, the M was money supply. Not for the modern quantity theory. Here's what we have now. This is money demand. So what this formula says is this. Money demand is proportional. There's that K. That's the proportion. Money demand is proportional to GDP in the economy. That is to say, the amount of economic activity we have, that's what determines the amount of money people want to hold. And this is economic activity or incomes. And so all we're really saying here is that money demand goes up and down in proportion to the size of the economy or in proportion to people's incomes. A while ago we had velocity of, what did I use? 5. So if velocity was 5, then this K would be 0.2. Right? 1 over 5 is equal to 0.2. What we will do next time, oh, and let me just put this in. Let's say GDP is $5,000. What we would say is, if people want 20% as much money holdings as their total incomes, then their money demand in this particular case would be 20% of $5,000 or $1,000. And the numbers all fit from what we were doing before, but now we have a little different interpretation. The quantity theory of money is a theory of money demand, not a theory of money supply. And we will pick up at that point next time. So long.